Hi everybody, welcome back to another video on working with properties of exponents. Remember that you can pause this video at any point in time to get caught up on notes or to work out practice problems, and then start the video back up to check yourself. Okay, so we're using the properties of exponents to write expressions. So on page 273, we're going to start with the division property of exponents, which says that if I am dividing two bases that are the same, I will subtract their exponents. So remember, the product property or the multiplication property of exponents said that if I'm multiplying two bases are the same, that I will add. So multiplication goes with adding exponents, and then the division goes with subtraction. So when dividing powers with the same base, subtract the exponents. Don't forget to divide the coefficients. And when I say divide, you're going to treat it like a fraction. Remember, we always try to simplify our fractions, and if we can do that, we should. If it doesn't simplify, we can just leave it as a fraction. I would not change it to a decimal. You could, though. All right, so let's look at example 1. Notice that 5 to the 4th and 5 to the 1st both have the same base. So what we're going to do is we're just going to subtract. Now, when we subtract and when we divide, order matters. So the number on top is going to go first in my subtraction problem, and then the exponent, the 1 down here, is going to go last since it's on the bottom. And we're just going to subtract those. So that's going to be 5 to the 3rd. 4 minus 1 is 3. And 5 to the 3rd power, since it is not a variable, I can go ahead and figure out what 5 to the 3rd is. And that's 5 times 5 times 5, or 125. All right, example number 2. I really have 3 to the 1st power up here, so I'm going to do a 1 first when I write that. So it's going to be 3 to the 1 minus 3, and 1 minus 3 is negative 2. Now, right now, that 3 to the negative 2 is in the numerator. Because it has a negative exponent, I want to rewrite it with a positive exponent. So that means I'm going to need to move that 3 squared down to the denominator where it becomes a positive exponent, and then I can figure out what 3 squared is. 3 squared is 9, so this is 1 over 9. All right, number 3, I want to look at this in chunks. I want to look at these as coefficients, and then I want to look at each variable individually, so then I'm going to just look at r's. So I'm going to kind of chunk the way that I look at this. 3 over 2 doesn't reduce as a fraction. Again, if you really, really wanted to write 1.5, I guess you could, but I want to encourage you to write it as 3 over 2. It does not reduce. Then let's deal with our r's. R to the 3 minus 1 is r squared. Now the 3 and the 3 over 2 is in the numerator, and r squared is going to be in the numerator as well, but that 2 from our 3 over 2 is going to stay in the denominator. So when I write this all, I'm going to have 3r squared over 2. So I really like the way that that looks versus the 3 and then the r squared slash the piece down here. I don't really like the way that that looks. I would rather write it as one fraction. Now you'll see some people that write 3 halves and then they'll write the r squared. I like to make one big fraction with it so that I know and I don't get confused as in what's in the numerator, what's in the denominator. I have everything in the right spots. All right, number 4. Look at 7/4. 7/4 doesn't reduce. Then we look at our k's. K to the 2 minus 3 is k to the negative 1. So when we really write this, we've got 7 k to the negative 1 in the numerator. Now we're going to have to fix that k to the negative 1 in a second. Over 4. 4 is still in the denominator because remember it's 7/4. 4 is in the denominator. And so in order to get that k to have a positive exponent, it no longer wants to be in the numerator. We're going to move it to the denominator. So we're going to write this, we're going to write this as 7 over 4k. Okay, so when you do your subtraction, it's the exponent on the top minus the exponent on the bottom, those powers. And then you have to decide if it's a positive exponent that you get as your answer, it's going to stay in the numerator. If it's a negative exponent, then you're going to have to end up moving it. So a lot of people, when they do that subtraction, you can do that in your head. You then have to make a decision. And so when I'm doing these and I'm just kind of going through really, really fast, I'll say, okay, this number minus this number, oh, it's positive, it stays in the numerator. Or this number minus this number, oh, it's negative. I'll move it to the denominator and then I'll make that number positive. So that's kind of how you can get it done a little bit quicker, a little bit less writing. You can do the subtraction in your head, but then you have to make sure that you place that variable in the right place. Okay, so some of you may need to think about it as an extra step. Those of you that are good with, oh, if it's positive, it's in the numerator. If it's negative, it's in the denominator. You can catch on a little bit quicker there. All right, let's look at number 5. 3/10 isn't going to reduce, so I'm going to leave it as 3/10. I've got b to the 1 minus 3. 1 minus 3 is -2. So already seeing that I've got a -2, I know that that b has to be in the denominator. It's technically, when I write this, 3b to the -2 is in the numerator, but that b to the -2 does not want to stay there. It's going to go down and join the 10. So it's going to be 3 over 10b squared. All right, let's look at 6. We've got 8/10. 8/10 is going to reduce to 4/5. So we always want to reduce that fraction. We're going to do m to the third minus m to the third. Or, I'm sorry, m to the third minus 3. 3 minus 3 is 0, and anything, with the exception of 0, to the 0 power is 1. So that really becomes 4/5. That's it. 4/5. No variable. They canceled each other out. Remember, anything divided by itself is 1. Let's do some more examples. All right, we're picking up some more variables, especially in those later examples. So again, if you think that you can handle this, you can pause the video and try them on your own, and then come back and see what we have to say. See if you're right. All right, we're going to start with 14/6. 14/6, they're both even. That's going to reduce to 7/3. And then we're going to chunk it. We're going to look at x's, then we'll look at y's. So with the x's, we're going to do 4 minus 5, which is -1. So we're going to play around with this idea of if it's negative, that means move it to the denominator. So that x is going to join the 3. With our y's, we're going to do 7 minus 4. That's y cubed. It's a positive. It's going to stay in the numerator. So that y cubed is going to be up there with the 7. So when I kind of pull all this together, I'm going to have 7y to the third, because y to the third was positive, stays in the numerator, all over 3x. X had a negative exponent, that sent it to the denominator. All right, let's look at number 8. 11/17. Both of those are prime. It's not going to reduce. Then let's look at our u's. We got u to the 4th over u to the 7. We're going to do 4 minus 7. 4 minus 7 is -3. That negative exponent is going to move that to the denominator. Now notice that we only have one v present. There's none in the numerator. There are v to the 9th in the denominator, so it's going to stay in the denominator. If you wanted to think of it as 0, v to the 0 on top, 0 minus 9, you would get -9. That would mean that you would move it to the denominator. You could also look at it as there's nobody to combine it with. It's not moving because it's a positive exponent, so it's just going to stay in the denominator. So this is going to be 11/17, u to the 3rd, v to the 9th. All right, number 9, 3 technically is 3/1. That's not going to change, so I'm going to just leave the 3 alone. Our m's, we've got m to the -4th over m to the 3rd. -4 minus 3 is -7, so we've got m to the -7th. That 3 is going to stay on top. It stays in the numerator. That m to the -7th, though, is unhappy. So when you look at it as 3m to the -7th, that's all in the numerator. The only piece that moves is the piece with the negative exponent. And so only the m to the 7th is going to move. Wow, I need to change that. I will in a little bit. This is 3m to the, make sure that this says 7, not 3. I'll fix that later. All right, number 10. look at each piece individually. So we've got 4 over 4. 4 over 4 is 1. I've got x to the 0 over x. So that's going to be 0 minus 1, which is negative 1. So that's going to end up being in the denominator. I have the y squared and the z, or the y to the negative 2, sorry, and the z cubed. There's nobody to combine it with, but I am going to have to move that y to the denominator since it's negative. So let's pull all of it together. That 1 from the 4 divided by 4, not really probably going to write that, but you can. So I'm really dealing with x to the negative 1, y to the negative 2, and z to the third. The only one that's happy where it is in the numerator is z to the third. The other two are unhappy because they have that negative exponent, so they're going to the denominator. All right, number 11, 2/3. That's not going to reduce. Let's deal with our h's. There's only one h cubed, so I'm not going to do a whole lot with that. It's just going to kind of stick around. Let's look at the j's. J to the negative third minus j to the first, or that's what I'm dividing. So I'm going to do negative 3 minus 1, which is j to the negative fourth. So I'm going to have to move that to the denominator. Let's look at the k's. I've got k to the fourth minus 1. So that's going to end up being k to the third. So that's got a positive exponent. That's going to stay up in the numerator. So I'm going to write this with 2/3. Actually, let's just do 2 in the numerator. 2 h to the third, k to the third, because the k to the third had a positive exponent. The h to the third also had a positive exponent, but had nobody to combine with. The 3 from the 2/3 is in the denominator, and then that j to the negative fourth that I can kind of see there is going to move to the denominator as well and become positive. All right, number 12. We already know that 2/3 doesn't reduce, but we've got x's, y's, and z's to work with. So let's work with the x's. So x to the 4 minus 2, top minus bottom, is going to be x squared. That's going to stay in the numerator. We've got y to the negative 4 minus negative 3. Well, negative 4 minus negative 3, you got to watch out for these guys. A lot of you think it would be negative 7, but it's actually negative 1. Remember, your key change. So that would change that to a positive, and that would change that to a positive. And so it's really the same as negative 4 plus 3, which is negative 1. That means that that y does not want to be in the numerator and wants to move. Let's look at our z's. Z to the negative 3 minus 4 is z to the negative 7. That doesn't want to be in the numerator. It wants to get to the denominator. So let's pull all of it together. Let's get our coefficients. So we've got the 2x squared over the 3 y z to the 7th. So with the exception of this error that I made up here, hopefully you're doing all right. You're able to pause the video. You're able to, basically we're just subtracting, reducing fractions and subtracting, making sure that the variables are where they want to be, if they want to be upstairs in the numerator or downstairs in the denominator. Now, in addition to that, we're going to do some power properties. This is called the product property, but sometimes you'll hear them as powers to powers. And the product property of exponents says that I'm going to multiply the exponents. And so it's like I've got a piece being raised to an exponent and the next extra exponent out here. And so you're going to probably see parentheses. That's a good sign to know that you're doing product property of exponents. And it's everybody inside the parentheses, everybody, even including like here, number 2, see that number, that coefficient, everybody, each piece gets their exponent multiplied by the exponent on the outside. So it's almost, I'm going to say almost because it's not quite true the way I'm about to word this, but it's almost like the distributive property for exponents. You've got to make sure everybody on the inside, their exponent gets multiplied by the exponent that's on the outside. So it's not really the distributive property, but you can kind of think of it like that. So when an exponent is on a set of parentheses, you're going to multiply the exponents. Do not forget the coefficient. So like this 5 in number 2, it's 5 to the first power. We have to remember we have to multiply that 1 by the exponent on the outside. So let's go through. Number 1, We've got 8 times 3. That's what we're going to end up multiplying. We're going to write our base down. So we're going to have n to the 8 times 3. And all we got to do is multiply. 8 times 3 is 24. So this is n to the 24th. All right, number 2, remember that each piece, so the 5 gets raised to that exponent that's squared, and the p gets exponent to the raised to that exponent that's squared. So this is really 5 to the 1 times 2, which is 5 squared. And 5 squared we know is 25. And then p to the 1 times 2. 1 times 2 is 2, so that's p squared. So bring it all together. We have 2 things inside the parenthesis. We have 2 things in our answer, two pieces. So we'll have the coefficient, 25, and then the p squared. All right, number 3, g squared to the 4th. So we're going to do g to the 2 times 4. G to the 2 times 4 is g to the 8th. All right, number 4, 8 has its own exponent. It's a 1. 8 to the 1 times 2 is 8 squared, which is 64. A to the 5, and then we're going to multiply that times 2 and get a to the 10th. So our final answer is 64a to the 10th. Now, we talked several lessons ago about negative exponents being raised to a power. So when you are raising a negative exponent to a power, you need to wrap it in parentheses. So when we look at number 5, -2 being raised to the -2 power, you want to wrap that -2 in parentheses because those parentheses are already there. They're already in the original problem. Okay, so you need to make sure that when you write this or when you're working with the calculator, you're making sure that that negative base is going in a set of parentheses. Now the negative on that -2, the negative piece is saying, hey, move me to the denominator. So I went ahead and moved it to the denominator. 1 over -2 in parentheses squared. Now that I've moved it to the denominator, it's no longer negative. And then -2 squared is +4. So this ends up being 1 over 4. Again, you need to stick it in your calculator. You need to put parentheses around it to make sure you get the correct answer. All right, let's look at z. Z to the 1 times -2 is z to the -2. Z does not want to be in the numerator. That's what that negative implies. So we're going to put it in the denominator as, you could write this as 1/4 z to the -2, but that's not, this is how I want it, 1 over 4 z squared. Okay. Let's look at number 6. That 2 has to be raised to the -3rd. Now, I didn't include parentheses here, but that's because that 2 is already positive. So just keep that in mind. All right, but the negative in the -3, that negative wants you to move the 2 to the denominator. So when I do that, it's now 1 over 2 to the 3rd. And 2 to the 3rd is 8, so this is 1/8. 10 is also going to get its exponent multiplied times -3. So this is 10, t to the -10 times -3. -10 times -3 is 30. So this is t to the 30. Now t to the 30 is a positive exponent. That means it wants to stay in the numerator. So the t to the 30 is going to stay on top. You could write it as this, like this, 1/8 t to the 30th. I think that that's kind of messy because you're playing around with, is that t in the numerator or denominator if you're not careful. I would rather you write it as t to the 30th, or you could have a 1 there, 1t to the 30th over 8. Remember, you can pause the video, and try some of these on your own. All right, number 7. So anytime you're doing this, I want you to take care of, it's almost like taking care of the parentheses first. Almost like distributive property again, but I want you to take care of the multiplying component of it, and then we can work on getting stuff together. Okay, so let's work with this first set of parentheses here. I'm going to, I see that I've got a power being raised to another power. So I'm going to use this product property. So I'm going to multiply, and I'm going to get f to the 4 times negative 2 is negative 8. Over here, I'm going to multiply. I'm going to get 3 times 10. That's going to be f to the 30. And now, since I'm multiplying these together, I can use one of my other properties of exponents, that multiply property of exponents. That says if I'm multiplying things with the same base, I add their exponents together. So that's going to be f to the negative 8 plus 30, which is going to be f to the 22nd power. So a lot of these things come in stages, and especially when you get more and more things going on. So work on the product property of exponents first, where you are raising all of the pieces inside the parentheses to that power, and do that, go through that. So you do have some stages of work that needs to be written down. And then once you get all those parentheses to go away, because after you multiply all of the parentheses, the exponents, those parentheses aren't necessary anymore. So once you get rid of all the parentheses, then you can work on almost like combining like terms. So just keep that in mind. All right, so let's look at number 8. So I'm going to do 2. It has its own power of 1. So it's going to be 2 to the 1 times 4 is 4. So 2 to the 4th and 2 to the 4th is 16. And then I have g to the 3rd. I'm going to multiply 3 times 4. 3 times 4 is 12, so that becomes g to the 12th. 4, it has a power, an exponent of 1. So I'm going to multiply 1 times 3, so I end up with 4 to the 3rd, which ends up being 64. G to the negative 1 gets multiplied times 3, so negative 1 times 3 is negative 3. So I've cleared out all of the parentheses. I've also went through and evaluated that 2 to the 4th is 16 and 4 to the 3rd is 64. I actually used a calculator for some of that. And I'm really going to use a calculator for 16 times 64. But so you can do those pieces. I kind of skipped some steps just because I ran out of room and wanted to be able to make it to where it wasn't too much. So if you're wondering why it seems like I'm not writing out the multiplication or the addition or stuff like that, it's because I'm trying to save space. But there's a whole lot that goes in from even this step to this step. All right. Next part, I'm going to multiply the numbers. So 16 times 64, I'm going to add the exponents on my g's. So I'm going to end up with 16 times 64 is 1024. And g to the 12th, g to the 12 plus negative 3 is g to the 9th. And then I just bring all that together. I've got coefficient of 1024, g to the 9th. Now, number 9, the first set of parentheses, there's a 1 out here. And multiplying things by 1 isn't going to change anything. So technically, there's nothing going to change in the first parenthesis. What change is going to happen is in the second parenthesis, and then I'll have to multiply. So I'll have to use that multiplication property of exponents to pull them together. But that first sub parentheses isn't going to change. So notice I just dropped the parentheses here. 3 to the 1st, 1 times negative 2 is negative 2. So that becomes 3 to the negative 2 power. Haven't done anything with that yet, but we will in a minute. K to the 2 times negative 2. 2 times negative 2 is k to the negative 4. Now, since both of these are negative, you can move them to the denominator. Or you can think of this as 3 to the negative 2 as 1 over 3 squared. 1 over 3 squared is 1/9. So that's what I did here. I did the 6 here. 3 to the negative 2 is 1/9. So 6 times 1/9 is 6/9. 6/9 reduces to 2/3. So that's my coefficient. My coefficient is 2/3. Now the j does not have anybody to be combined with. It has a positive exponent, so it's going to be up here with the 2. The k's I need to combine, but it looks like I'm going to have a 1 plus a negative 4. It looks like it's going to be a negative number. It's going to probably go in the denominator with the 3. So let's see. Yeah, k to the 1 plus negative 4 is k to the negative 3rd. So pulling it all together, I've got 2/3 j to the third, k to the negative third. And so I'm going to create a big fraction, one big fraction where I can see numerator and denominator. So I've got 2, the j to the third stays on the top, over 3, k to the third on the bottom because that was a negative exponent. Negative exponents move to the denominator. All right, number 10, we have, so we definitely have to do some multiplying with the first parenthesis. We have to do some multiplying with the second parenthesis. It looks like we have to do that for each one of those. So number 9 was a little bit unusual, but I wanted to make sure that you knew that this exponent doesn't get multiplied in here. This one has its own exponent of 1. So just keep that in mind in case that comes up again. All right, number 10, we've got to deal with that power. So we've got 25 u squared v to the 6. And then we've got 2 to the negative 2 u to the negative 4. So I'm just multiplying those exponents. Now I'm going to deal with this 2 to the negative 2. Remember that negative is going to move it to the denominator, make it 1 over 2 squared. 1 over 2 squared is 1 over 4. So 25 times 1/4 is 25 fourths. I have to deal with my u's, so I'm going to add their exponents. U squared, so 2 plus negative 4 is negative 2. That means it wants to get to the denominator, and I only have one v, so it's going to stay up in the numerator. So I'm dealing with 25 fourths u to the negative 2 v to the 6. So here's my final answer. The v to the 6 stays upstairs on top with the 25. And the u squared will go down to the denominator with the 4 because it had a negative exponent. All right, number 11. So I end up with 4 to the negative 2, x to the negative 4, y to the negative 6. Now, this negative, even though it isn't written like normal, it's normally a negative 1, I'm wrapping it in parentheses. Because you have to take each piece into account. And so because there's not a 1 written there, a lot of times people forget about it. So it really is negative 1. We're going to square it because there's a squared out here. And x to the 10th squared is x to the 20th. All right, negative 1 squared is 1, so I don't have to worry a whole lot about that. But watch out for odd exponents because that would keep it negative. Even exponents will make that negative 1 positive. So 4 to the negative 2 is 1/16. The 1/16 times my 1 here is still 1/16. I have to worry about bringing my x's together. So I've got x to the negative 4 plus 20. That's x to the 16th. That's going to want to stay in the numerator. I've got y to the negative 6. That's going to go in the denominator. So let's pull it all together as one big fraction. I've got x to the 16th on top. If you wanted to put a 1 with it from the 1/16th, you could. The 16 and the y to the 6 are in the denominator. All right, number 12. We've got negative 2 squared, a to the 6, b squared, because I'm multiplying those exponents. And then times c to the negative 3rd, a to the 21st power. Negative 2 squared is 4. So I'm going to deal with that in a minute. A to the 6 plus 21 is 27. And so I really have 4, a to the 27th, b squared, c to the negative 3rd. And the only one that's unhappy, the only one that wants to get to the denominator is that c to the negative 3rd. So I'm going to rewrite this as 4, a to the 27th, b squared over c to the 3rd. All right, quotient properties. So now we're picking up on more fractions. And the only thing is that if I have something on top and something on bottom and it's all being raised to a power, again, I'm going to see parentheses. That's a big signal for me. I just have to make sure everybody inside, including the stuff in the numerator, which we just worked with, but also the stuff in the denominator, that all of their exponents get multiplied by that value that's on the outside. So everybody. When I have a big old set of parentheses with a numerator and a denominator inside, it doesn't matter. I'm going to multiply every single piece's exponent by that exponent that's outside. And that's usually the first thing that I want you to do. I want you to take care of all of that stuff. Now, there's other ways to handle and simplify, but that's where I'm going to start with a lot of this. Is just, it's again, almost like the distributive property, I'm going to multiply every single piece's exponent by that exponent on the outside. We may get to a couple examples where I do it a little bit differently, and I can show you how, but I want to be pretty consistent, so that's what I'm going to start with. So let's look at number 13. You've got a over 2, all raised to the 4th power. A and 2 both have an exponent of 1, so I'm going to multiply both of them, their exponent, by that 4 that's on the outside. So it's going to be a to the 4th over 2 to the 4th. Now 2 to the 4th can be evaluated. I can figure out what that is. And 2 to the 4th is 16. So this is a to the 4th over 16. That's it. All right, 14. So we're going to have every piece, their exponent is going to be multiplied by 2. Remember, 25 has an exponent of 1, 5 has an exponent of 1, so we're going to multiply everybody's exponent by 2. So I'm going to have 25 squared, my personal favorite, 625. And then c, negative 1 times 2 is c to the negative 2 power. And then 5 squared is 25. So that's in the denominator. Then I'm going to kind of clean this up. 625 divided by 25 is 25. So 25 c to the negative 2. And then I'm going to work with that negative exponent. That negative wants to be, that c has a negative exponent, wants to be moved to the denominator. 25 is happy up in the numerator, so don't move it. So it's going to end up being 25 over c squared. Now, the order in which you do things, especially when there's a whole bunch of steps, the order is kind of, what do you see, what do you notice, what goes first? There's no real wrong order, but like I said before, I'm going to focus right now on the very first thing being multiply my exponents. So number 15, we end up with negative 2 squared d to the 22nd, because I multiplied 11 times 2. F, 5 times 2 is 10, so f to the 10th. 4 squared, and if you know 4 squared 16, you want to write 16 there, go for it. D to the negative 4th, because negative 2 times 2 is negative 4, and f to the 4. Then your goal is to kind of clean stuff up. So it's been a while since I wrote out these notes. So let's see what I did next. Okay, so I did negative 2 squared is 4. D to the 22nd. I pulled this d to the negative 4th up to the numerator and just wrote it as a positive. So that's something you can do. If you want to move negative exponents, you can. F to the 10th over, here's 16, f to the 4th. So that was one thing that I did, was I evaluated my coefficients and then I moved my negative exponent. All right, so in the next one, I should be reducing that 4/16. 4/16 is 1/4. Here I'm adding my exponents. 22 plus 4 is 26. And here I should be subtracting my exponents. 10 minus 4 is 6. And then if you subtract and you get negative numbers, you could still move them. But everybody's positive. Technically, you don't need to write the 1 here, but I did this time. Let's look at some more examples. All right, number 16. So we should probably do 4 to the 3rd, x to the 15. We did 5 times 3. Y to the, there's a 1 here. 1 times 3 is 3, so y to the 3rd. 16 to the 3rd, x to the 3rd, y to the 4 times 3 is 12. And then I'm probably going to evaluate. So 4 to the 3rd is 64. 16 to the 3rd is 4,096. I want to reduce that fraction. All my exponents are positive, so I have some division. So I'm going to be with my x's, I'm going to be subtracting 15 and 3, and then 3 and 12. So let's look, 64 over 4096 is 1/64. X to the 15th over x to the 3rd is x to the 12th, because 15 minus 3 is 12. 3 minus 12 on my y's is negative 9. And so the last piece that I need to do with this example is I need to move that y to the negative 9 because it is negative exponent. We don't want it to be negative. We want it to be positive. So I'm probably going to get rid of that 1 as well. So that's going to be x to the 12th in the numerator, 64, y to the 9th in the denominator. All right, 17. We've got everything being raised to the 4th power. So I've got 5 to the 4th, x to the 12th, because that's 3 times 4, y to the 4th, because that's 1 times 4, over 20 to the 4th, x to the 4th, y to the 20th, because that's 5 times 4. So 5 to the 4th is 625. And then 20 to the 4th is, oh my goodness, 160,000. And we're going to need to reduce that fraction. So 625 over 16,000 ends up being 1 over 256. I'm subtracting my exponents on my x's. So 12 minus 4, that's the 8. On my y's, 4 minus 20, that's the y to the negative 16. And so because that y is to a negative exponent, it's going to go to the denominator. So this is going to be x to the 8th over 256, y to the 16th. All right, number 18. We're going to have negative 7. Notice that I've got that negative 7 wrapped in parentheses so that I can make sure that that negative gets taken care of as well. I'm raising everything to the negative 4. I do notice here I got rid of c to the 0 because we know anything to the 0 power is 1. I have one less thing to work with if I kind of mark through, cancel that c to the 0 out. So just a kind of helpful hint, shortcut a little bit. 2 times negative 4, so that's 8 to the negative 8. B to the 3 times negative 4, that's b to the negative 12. Lots of negative exponents here. 3 to the negative 4, a to the negative 12, b to the negative 16, c to the negative 12. Now you can do the subtraction piece or you can move them. I think I moved everybody. I swapped everything. So everything in the numerator traveled to the denominator. Everything that was in the denominator is now in the numerator. So that's one way you can clean that up. And then figure out 3 to the 4th, that's 81. Negative 7 to the 4th is 2,401. And then I'm subtracting my exponents. 12 minus 8 is 4. 16 minus 12 is 4. And c to the 12th just stays on top. Everybody's got a positive exponent. I don't think 81 over 2,401 is going to simplify because you just have 3's and 7's. Nothing's the same. So that's going to be the best you can do, the simplest form that can be written in. So really, I highly recommend going through and multiplying these pieces out. But I think in some of these examples here, especially when they get a little crazy, look at this. We got parentheses with exponents, and then more parentheses with exponents. So we may look at some shortcuts. We'll have to look at that. But what I would do for stuff like this is I would work with the parentheses that are on the inside first. So like this 2, I would be multiplying everybody's exponent by that, and then do a round where you're using the bigger piece. You could technically multiply these guys together. It just kind of depends on what you kind of notice and what you kind of see first. So number 19, looks like I did that where I multiplied everybody's exponent. There's a 1 there, there's a 1 there. I'm multiplying by 2. So I got negative 2. Remember, there's parentheses already around it, so I want to make sure I keep those parentheses. So negative 2 squared, x squared. And then let's see what I did next. Okay, I went ahead and cleaned that up. So negative 2 squared is 4. And then I've got my x squared. And then now I'm going to, again, it's almost like the distributive property. Everybody inside, its exponent's going to get multiplied by 3. Yep. So I got 4 to the 3rd, x to the 6th, because I'm multiplying by 3, the exponent's by 3. Don't forget the 3 in the denominator needs its exponent multiplied by 3. X cubed, y to the 6th. And then I'm going to start cleaning this up. So my 4 cubed is 64. 3 cubed is 27. I'm going to do 6 minus 3 on my x's. And that's going to be an x cubed. That's going to stay in the numerator. My y to the 6th has nothing to combine with, so it's going to stay in the denominator. Now, Number 20, let's see if number 20 I did what I want to do. Yeah, so number 20, see how all of this is raised to the 0 power? Just get rid of it. Anything. It doesn't matter how many pieces. Anything to the 0 power becomes 1. And that allows you to get through the problem a little bit faster. Yeah, you can distribute that 0, multiply through its exponents by 0, but it's going to give everybody a 0 exponent and turn everything into a 1 anyway. So I like to get rid of those first. So then we're just going to focus on 1 cubed, which is 1, negative 3 to the 3rd power, x to the negative 3rd power, y to the 6. Remember, we're multiplying everybody's exponent by that 3 on the outside of the parentheses. Well, negative 3 cubed is negative 27. And then I'm going to have to end up moving that x to the numerator because it's got a negative exponent. It doesn't want to be in the denominator. Now that negative on the 27, sometimes you see it written kind of out. Remember that we talked about this in class. So that's called a floating negative. So it could float up to the numerator. It could be just out in front. Doesn't have to stay with the 27. But that, remember, it's not a negative exponent. It's a negative coefficient. So we're not going to be moving that anywhere. It doesn't mean that the negative 27 wants to be out of the denominator. All right, 21. Everything's raised to the negative 1st power. I'm probably going to take care of that denominator first. So, yep, so 2 to the 3rd and c to the 6. 2 to the 3rd is 8. Now, I want to talk. I don't know. Let's see. Yeah, I did it in this one. Okay, so sometimes people are like, look at this. I can reduce this fraction. Let me reduce this fraction first. So this was a good example to say, hey, I know 16 divided by 8. I can do c to the 4th and c to the 6th. I can subtract those exponents. So you can work on the inside and work on simplifying down the inside. But then don't forget, you still have to deal with that exponent on the outside. So this case, I did 16 divided by 8 is 2. And then c to the 4 minus 6. 4 minus 6 is negative 2, so that moves that c squared down to the denominator. And then I'm going to multiply everybody's exponent by negative 1. So it's going to be 2 to the negative 1st over c to the negative 2. And then that means that they both want to trade places. 2 to the 1st wants to go on the bottom. C to the negative 2 wants to go in the numerator. So that's a different way to do it. But still, I do have to apply this multiplication product property. Anyway, I just did it at the end instead of at the beginning. So, different way to do things. So you can simplify the fraction and then go through and apply that property of exponents. All right, that's the last problem for this video. I'll see you in the next video.